Alrighty, so questions. I am well. How are you? Awesome. What? Because I'm tired of suits until they fix the air conditioning, heating, everything else environmental. So I'm going for comfort. Be comfortable. We're doing Java, so it's good stuff. So PA1 questions. Everybody confident they're like on the right track? Yeah.
So like with I was trying to set up my program, so it doesn't come with one.
So it would what?
So like if you have like a whole number, like 3 over 1, so it wouldn't print the 1.
Okay.
And I just assumed you could just put like a conditional in your 2 string or 2 method, 2 string method, and that didn't work.
What did it do instead of working?
Well, like I said, like if denominator equals 1, then return numerator. If not, then like the fraction string, and it would, yeah, it would tell me that you can't pass an int.
So there's a subtlety here. I just freaked out my poor computer. All right, so don't call your classes S, give them real names, but I couldn't think of one right now. Demon, no. Never realized denom was a palindrome for demon. Okay, so just a piece of what we're doing inside 2 strings. So we're going to take the numerator, we're going to concatenate a slash, concatenate the denominator, stick that in a string. We would return that from 2 string. But just to play with it here, let's just go ahead and print that out. So this will go ahead and print out our 5 over 1. Okay, so here's what's going on. So this works fine. This is not going to work, because when I try to compile this, it'll say incompatible types. Required string found integer. So this, or if I just say return num and I'm supposed to be returning a string, it'll say I'm expecting you to be dealing with a string, but num is an integer, and it's going to get upset about that. The reason that this line works is because this concatenate operator tries to turn everything into a string. So we can't really concatenate an integer to a string, but Java will say, okay, well, since I need a string here, let's convert this integer to a string, right? And so this is a string concatenated with a slash, concatenated with another string. But if you just say haha equals num, or if you just say return num, it thinks you're returning an int. And that's going to upset it. So here's a cheap way to turn it into a string. Just concatenate an empty string to it, and Java will do its thing where it says hey, I need a string. Let's turn num from an integer into a string. And that'll compile and it'll execute fine. And you can also do this. Bless you. Because num should have a two-string method. Now I don't know for sure that this will work. Yeah, that's not going to work because int's a primitive. So ignore that. But if it was some other kind of thing, you could force it into a string like that.
I'm pretty sure you can type in like integer. There was certain cast that showed that you can't cast it to a string method.
You can cast it?
Yeah.
Yeah.
So in the programming assignment, each method, right, is defined as, like, for instance, just the add function is defined as a fraction, returning a fraction. If I wanted to, could I make it return a string instead, or do you want it set up?
It's got to return a fraction. If it returns a string, it's going to be pretty much 0 points because it's not going to work on any of my test code.
Okay.
So yeah, add, sub, mul, div all have to return fractions. If we wanted to return a string, we could take that fraction and we could just say .toString paren, and now that's going to return the string associated with a fraction. But that's exactly what the toString method is there for. Yeah.
In the programming assignment page, for the testing section, do we just copy and paste that whole thing without one code?
Yeah, but I also posted it on the Linux server under /temp/pa1 test or pa1 test b, I think. There are two versions of it. So if you don't want to copy and paste, you can just copy it from there. It's time to get a network connection. All right, other questions? So we were playing with stack class yesterday. We did this again in the afternoon section, so this code's slightly different, but effectively the same. So this was the class that you built together, and it implements a stack. We can push, we can pop, we can tell if the stack is empty, and we can tell if the push succeeded because it returns a Boolean telling us success or failure. So if the stack's full, it doesn't push and it returns false. And we had a main method that did some stuff. It pushed a few things and then we popped off one at a time and printed out. But let's look at the stack itself. So let's just print out the stack with a print line. And when we do that, it tells us s equals, and it's our old class name stack at sign and then hex number. Right, not very interesting. So suppose we wanted to be able to actually print out the stack. What might we want to see if we tried to print s, and s is a stack? What could be a reasonable thing to print out?
Sequence of numbers?
The what?
A sequence of numbers?
Sequence of numbers. We could make it so that when you try to print the stack, it shows you everything that's in the stack. Or maybe it shows you what's at the top of the stack, or maybe it just prints out this is a stack. Right? We could define how we want a print method to respond when we try to print a stack. So how do we do any of these things? What do we have to write? Right, we want a two-string method. So public string, two-string with no arguments. Well, let's just use this as a debug. Let's just see what's in the stack. Let's return a string that has a list of each element that's in the stack separated by spaces. So I'm going to make a empty string called return value, and I'm going to do the following. So what's our stack called? Stack.length. Actually, let's just go up to the stack pointer. And let's just concatenate the next element from the stack array, and we'll put a space on the end. And we'll do that inside a loop across all the elements from 0 up through SP minus 1, because SP isn't part of the stack. It's where we're going to push the next thing on the stack. So we'll jam all of those together into a string, and then we'll just return that as the value of toString. Does that make sense? So compile stack.java, go ahead and run main, and now when we printed out s, it said s equals 12, 200 minus 25, 100, which is the list of things from the first thing we pushed down to the last. So you can do whatever you want with toString, right? I asked you to do something very specific with it in this fraction class, but if you're making your own class, you can do whatever you want. You don't have to do anything. And when someone tries to convert it to a string, say by concatenating it, it'll just print out class name, @ hex number, but you can define toString however it makes sense to you. And sometimes it makes sense to be able to print an object, sometimes it doesn't. So it's your call as the programmer. Just for fun. We put commas on the end. Right, it tells us our stack equals, and we've got that annoying trailing comma there, which always pops up on assignments for a few points. So how do we get rid of that? Oh, we could use trim. That would be a sneaky way to do it. We could just trim off the last character.
We could join with commas.
Could do what?
We could join the array with commas.
Join the array with commas. What does that mean?
Like, insert the commas before. Isn't there or is that only on strings that you can join an array of strings?
We could turn it into a string and then try to put the commas inside with a join or something. Yeah. Yeah.
If I is equal to stack pointer minus 1.
Okay. So that's the probably most direct way. So. Right, so the last time through this loop, I will be equal to SP minus 1. So if I is equal to is not equal to SP minus 1, go ahead and add a comma at the end. And what are we telling it to do? We're saying add the next number, and if it's not the last number, put a comma out. And then add the next number, and if it's not the last number, add a comma after that. Which is kind of exactly what we wanted to do. Alright, so now you got a nicer looking toString from stack.
Is there any array slicing in Java?
Any what?
Array slicing, as in where you can say array square bracket 0 colon minus 1. So it'll bring from 0 to the last character, excluding the last character.
There could be, but remember, strings are not arrays.
Right, okay.
Right, but we could find the length of the string and then take a substring. In fact, this is worth looking at anyway. Let's just say string class Java. And we looked at this last week, but it's worth a relook. Strings will let us do things such as substrings. So we can say give us a substring beginning at a certain point, or give us a substring from some initial index up to some final index minus 1. And so if we found the index of the last character, which is just the length minus 1, we could take a substring from 0 up to string.length paren minus 1, and that would trim off the last comma. But strings, because they're a whole class, right, they're not just an array of characters, they have lots of things we can do with them. Lots of ways to break them up and put them together and change them around and pull off pieces of them and so on and so forth. And make sure when you start working with strings, which you'll be doing in PA2, make sure you go through here and look at some of the options available, because they'll save you time. And switch. All right, any other questions, comments? How's the sign-in sheet doing? Is it still making its way around? All right, hey, did anybody not sign in? A few people walked in late. If you didn't sign in, come and sign this at the end of class. I'll leave it up here. All right, so let's play with something. Let me refresh something first here. We've been changing stack.java, right? That's the file that contains our Java code, and I've been recompiling it saying Java C stack. You may have noticed I never recompiled my main program, my main class, main.java. The reason being that unless I want to do something different in here, well, let me do this. So here's what main does. It says s equals all of this stuff. Let's change the stack class, and let's change our toString method. And let's just have toString return ha ha ha. Right, now our main.class is still from 10 minutes ago, right? It's compiled at 10:11. We've just recompiled our stack.class. But if I go ahead and I run main, it uses our new toString method in the stack. Right? The reason is if I change stack.class, I don't need to do anything to main.class. Main.class was the bytecode, the compiled version of main.java that includes using the stack class. So when the JVM is running my main method and I need to create a stack, it's going to look for something in my current directory named stack.class, and that's what we recompiled.
So in main, if you tried to use like stack.haha, which doesn't exist, that would be a compile error. So if you change stack after the fact, after having compiled main successfully, would that be a runtime error?
Yeah, so let's try this. Let's compile, let's edit stack.java, and let's just get rid of the push method. We'll just call it ppush. So we recompile stack, that's fine. We go ahead and we run main, and it'll say no such method error. Stack.push. So that's a runtime. All right, so let's talk about something that I didn't want to talk about, but people are finding out about it anyway. So let's go back to a rectangle class. So a rectangle has a height and a width. And I'm going to be lazy. I'm just going to give default dimensions. So when you construct a rectangle, it's just going to be a 5 by 7, and area will give us our area. So R is a rectangle, and we'll just print out the return value from r.area. It should just tell us that the area is 35. If we have a semicolon. Alright, so area is 35. Okay, so I just want this to have something that we can play with. When I say height inside this method, what variable am I referring to? Clearly I'm referring to this integer here, correct? Okay, this is something that we call a class variable. It's part of the class. If down here I say something like integer x, and I say x equals 12, the x that I'm referring to here is part of this area method. It's local. Okay, and so this is the sense in which I mentioned last week. It's kind of like height and width are global within the class. They're accessible by different methods throughout the class. Now, suppose I do something like this. Suppose inside area I say integer area, integer height, height equals 2, and then I return height times width. So when I ask for the value of height, what am I going to get? Am I going to get 2 or am I going to get 5? What's your best guess?
2.
Going to get 2. It's just like if you have global variables in C, but you define a local variable. The local variable is always the thing that you access. So I have a global named height, but I have a local named height, and I say height equals 2. It's referring to my local variable. So this is about scoping. And we always grab the thing that's in the narrowest scope, the thing that's most closely defined. So when I say height here, it's using this local variable, which is a height of 2, And so it's going to tell me that my area is 14, 2 times 7. What happens if I really want to get to the height of the original class variable? If I want to get to this global height, even though I have a local variable called height. So from main, I could say something like r.height, and that would refer to the class variable, right? If I say r.height in here, there's no way it's going to give me this height, right? r.height means this. So if I had a way here to say r.height, I could get back to my original, but r is not going to work there because that only worked in main because our object was called r. But if our rectangle was called r2, I would need r2.height. So what we're looking for is a way to refer to a class variable named height in this current object. Okay, so there's a keyword for this, and the keyword is this. So this gets a little existential. This is a way that the object's code can refer to itself. So we've just introduced ego into this poor domain. So this means me, right? My class variable height for whatever this object is. So if you do that, even though we have a local variable height which is 2, this dot height is getting the original class variable which is 35. And if you don't happen to have local variables with the same name as a class variable, you don't need to worry about the keyword this.
You also use self.
Use what?
Self.
Self?
Yeah, I've seen people using self.
I don't know self. Interesting. Oh, Python uses self. I think that's similar.
I saw someone using self in my browser. So.
Really? Okay. I've never seen it in the Java program. I'll have to play with it. But it sounds like a similar concept. So, so you don't need to do this, okay? And I'm seeing a number of people writing code for PA1 and it's got this all over the place, okay? It's not necessary usually. It's only necessary if for some reason I really want a local variable named height, but I also want to sometimes be able to refer to this class variable with the same name. And then if I just say variable name, it's local. If I say this dot variable name, it's the class variable. We can also use this to access methods, but we don't have to unless there's an ambiguity. So if I say some method name in here, it's going to run that method from this current object. Okay, so here's where you see this used most often. Let's make a constructor. So that's the constructor we made before for a rectangle. And I called my arguments h and w, and then I just set the height equal to h and the width equal to w. And you've heard me say, try to use reasonable variable names. Avoid things like h and w. It would make more sense if we actually called these things something like height and width. But if we do that, then these statements look like this. And those are silly statements. Height equals height doesn't do anything. What we really mean here is I would like this height to be set equal to this height. And I'd like this width to be set equal to that width. And this is probably the most common place you'll see the keyword this used, because we can make that happen by doing the following. This dot height equals height, this dot width equals width. But again, it's not necessary. It's convention. This is usually what people do when they make a constructor and you're passing in things that are being stored in class variables. You usually use the keyword this. But you could also just call this, you know, height argument, width argument, and then say height equals height argument, width equals width argument, and it's just as clear. But if you want to use the same variable name, you can get away with this. So now I can construct with a pair of dimensions, 12 by 15, and it'll tell me my rectangle is 180, as it should be. Okay, here's the other thing we can do. Suppose we want to construct a square. Well, to construct a rectangle with a single argument, we want to create a square rectangle, a rectangle whose height and width are both that argument. So I already have a constructor that takes two arguments, a width and a height. So I could say this rect side comma side. And that'll construct my two dimension rectangle. I knew I was going to get that wrong. Thank you. Oh, but I gotta change my main program. So let's make a 12 by 12. So we'll construct with a single argument. So we got a 144. So what did I do? I defined my new constructor that takes a single argument, and I called the constructor that takes two arguments. So if you have a constructor that's doing 85 billion things and you want to make a slightly different version of it that takes different arguments and does a few other things, right, you can punt to the constructor that you already have and save yourself from some work. So let's make a default constructor that takes no arguments. And that's just going to create a 1 by 1 rectangle. There you go. Or I could have said this parentheses 1. And it would make a square 1 by 1. So there's our default constructor being called. And there's our 1 by 1 rectangle. So again, it doesn't give you anything that you can't already do if you don't mind typing extra stuff in this case, or using different variable names in the case of arguments to methods, for example. But it's an option. and it's a concept that I want you to know in this course, so it'll show up on tests and stuff. But if it's confusing you for now, just avoid it, right? It's not necessary. And it'll make sense the more that you work with objects and classes and get into that mindset, and at some point come back to it and we can revisit it. But that's the full story on this keyword. All right, questions on that? All right, let's learn a new class. Let's talk about scanners. So we know how to display things from a Java program. We can use system.out.print or print line. That sends things to standard out. We haven't talked about how to input things. And possibly for PA1, but particularly for PA2, it's going to be useful for developing and debugging to be able to do input from your program to help you not have to keep making new test cases and recompiling. So we want to be able to respond to user input. And the easiest way to get input is to use the scanner class. So scanner is a general, it's kind of like scanf, right? It's a way to pull input in and do some processing on it, do some parsing, and so on and so forth. And we're going to use this system.in object that's going to be equivalent to standard in Unix or C. That's where we're reading from. System.out is like standard out. That's what systemout.println is printing to standard out. And whatever we learn about scanners for reading from standard in, we can also use to read from files by constructing a scanner with an argument like this. New file in the name of a file name instead of system.in. And then everything that we do with scanner is going to work. So scanner is like everything. It's a large class. Lots of ways to construct, and then bunches of methods we can use. But let's use a really simplified version of this. So here's a class called scanTest. Okay, so I'm going to construct a scanner. I'm just going to call this SC for scanner. So this is going to construct a scanner for reading from standard in. And there's two methods we're going to use with this. We're going to use hasNextLine and nextLine. So hasNextLine is a method that basically looks to see if there's a line of input ready to be read. And then if there is, we can call nextLine. That'll read the next line and it'll return a string. And this reads up to the end of line separator, and it ignores the end of line. So it's kind of like fgets, except we don't get the \n tacked on to the end. So this is going to let us read one line at a time from standard in. And if we hit end of file, then hasNextLine will come back and return false. And we'll kick out of our loop. So while our scanner has another line available for us, let's go ahead and read that next line and save it in this string called temp. and I'll print out temp equals angle bracket. I'll concatenate the string temp, I'll concatenate a closing angle bracket, and then I'll print out length equals, and I'll call the length method, so it has parentheses on it, for that string. So we'll see how many characters are in this string that we just got. And we're just going to loop on this until SC no longer has a next line. And then we're going to call close, which basically undoes what we did when we constructed. And then we'll just exit. So this is hello world for doing input from standard in. But I get an error. Cannot find symbol scanner. Say again?
You have to include the modules.
Yeah, so this is like trying to do square root. So some things in C, like printf, are predefined for us. They're always included. Some things we need to explicitly include. Same thing with Java. So an uppercase string, that class is always available, but scanner is not. Because if everything in Java was always available, it would be really slow to sort through all the possible things that we might be referring to. So in the top of this Java documentation, you always see a line that looks like this. This tells you where the scanner object, in this case, is located in something called java.util.scanner. So we need something like an include statement, but the keyword is import. And it should be in uppercase S. And so that tells it to look in the Java collection under the util. Underneath there should be a scanner. So now we compile it, it works fine. I can run it with Java, and it's sitting here waiting for input. So I can say this is a test, and it tells me my string was this is a test, and its length was 14. I can say hi, and it tells me my string is hi and length is 2. I can hit just an enter, and my string looks like it's empty, and it tells me the length is 0. I can type weird things, and it tells me my string was something with a length of 3. And my string was actually escape, left bracket, and the letter A, which is computer speak for an up arrow. And when it tried to print it out, it actually moved up one line and printed it out up here. And then if I hit Control D, has next line returns false, and my program exits. Right, and I can run this, and I can redirect standard in just like anything else in Unix. So I can redirect it from the source code, and now it's looking at its source code and doing the same thing. Alright, so that basically gets you on the air for like reading a line at a time from standard in. But you can do more nuanced things. For example, if you know that you want to read an integer, you can say has next int, and it'll tell you true if the next thing in the input stream is an integer, and if it is, then you can say next int, and that'll give you an integer value. let's read integers. So while sc dot has next int, I'll say temp equals sc dot next int, and I'll print temp equals print out the value of temp, and also print out the value of 2 times temp, just to convince ourselves that it really is an integer and not just a string, because they look the same when you print them.
I think you're using a semicolon. The system output.
That was a weird message, though, if that's where it came from. Oh, I forgot the .java too. Okay. Alright, so scan test 2, so I can put in 45, and it tells me temp is 45, 2 times temp is 90. Then I did 45.6 and it exited. Right? It's not an int. And so has next int returned false, and my while loop kicked out. So this starts to get into this thing that I preach in 224 about not using scan. Use scan, right? So it's cleaner potentially to read an entire line and then process that line. If I use scan and I'm expecting an int and someone types in something that's not an int, has next int will fail, and you got to deal with that afterwards. All right, but that's enough to get you going on the error. If you just want to make test cases and such, that'll work for you. All right, so I'll see you tomorrow.